In this video, I'll be helping you with the ALEKS problem type called graphing a parabola of the form a y squared plus by plus cx plus d equals 0, or a times x squared plus bx plus cy plus d equals 0. And to start, I'm actually going to change this form to something that's more familiar to us and a little easier to work with. The standard forms that I have listed here are much nicer to work with because I can see from the standard forms what h and k values are. That'll allow us to find the vertex. I can also see what a is, and I know that if a is positive, it opens either up or to the right. If a is negative, it opens either down or to the left, depending on which form we're working with. So this is a much better form for graphing parabolas. And if I look at this example that we're given, I can see that the x variable is the one being squared and the y value is the one that is just by itself. So this is the form that we would like to use. And you can see that it is solved for y with everything else on the other side of the equation. But I also notice that I have this quantity being squared, and that's something we're missing in our example, but we can get there by completing the square. So starting with our original, to get it in this form, I'm going to first leave the x variables on the side where they are, but I'm going to add the y and subtract the 2 from both sides so that the x variables are by themselves and we have y minus 2 on the right hand side. From here, I can start to complete the square on the left-hand side by first factoring out the 3, leaving me with an x squared minus 2x on the left-hand side. And then to complete the square, I need to take half of this middle term and square it. So half of 2 is 1, squared is 1. So I need to add a 1 inside this parentheses. But notice that when the 3 gets distributed, I actually just added 3 to the left-hand side. So in order to keep our equation balanced, I must also add 3 to the right-hand side. From here, everything inside the parentheses is now a perfect square. This is x minus 1 quantity squared equals, I now have y plus 1 on that right-hand side. And now we can solve for y to get this standard form. I would subtract 1 from both sides, and then just writing the y side first, I have y equals 3 times x minus 1 squared minus 1. Now that we have standard form, I can tell that the vertex, which is hk, our h is what's being subtracted from x. So here h is 1, k is what's being added to the x squared side. In this case, we're adding a negative 1. So we have our vertex. It is at 1, negative 1. And I know that since the a value is 3, it's positive, it's going to be opening up. So I know that we'll have this basic form. To get a sense of how steep it opens up, I can choose a couple of values on the left and right. So we have our vertex 1, negative 1. I like to go at least a couple of values to the left and right. So I can go a couple of values to the left for negative 1. A couple of values to the right would be 3. Plugging in these x values, I get y equals 3 times, if I let x be negative 1, this would be negative 1 minus 1 squared. So y equals 3 times negative 2 squared. Y equals 3 times 4 minus 1. So y here equals 12 minus 1, 11. So my second point is negative 1, 11. Plugging in x equals 3, we would have y equals 3 times x equals 3 minus 1 squared minus 1. This gives us a positive 2 squared minus 1. So again, 3 times 4 minus 1, y equals a positive 11 again. This time when x equals 3, we have positive 11. So we can see that this is a very steep parabola as a result of that coefficient 3 that's in front of the squared term.